Almost 80% of students were awarded 0 marks for this question, so let's go through it. This question gives us two functions, g and h. It wants us to find transformations of h so that its local minima will have the same coordinates as that of g. And because this is exam 2, it's important that we can use our CAS calculator as much as possible to help us for this question. The first thing I'm going to do is define the functions g and h in my CAS and also graph them so I know what I'm working with. Here you can see I've defined functions g and h, and then we can go to our graphing function on the calculator to graph g and h. So here, blue is g and red is h. Next, we want to find the local minima of g and h, and to do that, we have to find the points where the derivatives of g and h equal 0. Using our CAS, we can find the derivatives. Then using the solve function, we can find the x-coordinates for which the derivatives equal 0. This is where local minima and maxima will occur. G and h have both given us 3 values of x for which the derivative is equal to 0. Going back to our graph, we can see that the local minima occur at x equals -1 and 2 for g of x, and negative root 10 on 2 and positive root 10 on 2 for h of x. Now that we've found the local minima, we can use these to answer the question. The first transformation we can do is shift the red graph h of x up so that it is now in line with g of x, and so that's a vertical translation of 9/4 units up. Now the spacing of the local minima for our red graph need to be the same as the spacing of that of the blue graph, so that's 3 units apart. This means we need a dilation by factor, let's call it I, on the x-coordinates of our red graph. Then we want to apply a horizontal translation by j units, so that the local minima coordinates of h become the same as g at -1 and 2. Now we've actually managed to set up simultaneous equations to solve for I and j, which we can use our CAS for. So that gives us the final answer of dilation by a factor of 3 root 10 on 10 from the vertical axis, and a translation of half units to the right. This question was the end of a 9-part section, so let us know in the comments if you'd like explanations to the other parts.